It is always recommended that you are on the latest operating system. You can check if you are on version 4.5 or later. The most recent version is 5.2.
If you click option 5, which will be settings, and then if you look at status, which is number 4, it should display your current version. So that's my home screen. Now if I click 5 and then 4, it gives me that I'm on version 4.5. The next thing I'm going to do is to insert a graphing application, and that's where the application is. Now if I go to menu and if I go to the settings, which is option 9, I need to make sure that my graphing angle is in radians for the specialist mathematics course. The geometry angle could be in degrees, it does not matter because we don't use that very often. So that's my setting there. Now if I do control menu, it actually gives me the graph entry line. Now I just want to remind you, if you want to toggle between the graph entry line and the full graph screen, all you need to do is do control G. So control G, that's the full graph. Control G again will give you the graph entry line. So if I do control menu, it gives me the option to enter the graph in terms of a function, or I can do a graph for a relation. Then there are graph equation templates, several of them. So I have templates for line, parabola, ellipse, hyperbola, conic, circle, and so on. Then I can actually go and do a graph in the parametric form, which is number 4, graph in the polar form, and then we'll also be looking at differential equation graph. So let's start with the first of the graphs, which is a function. Now I'm going to enter a function. Now I don't have to call it f1, so for the sake of convenience, let's just go and call it as g of x. Now let's go and do a very basic graph. So we are going to do a sine graph, and let's say we're going to do sine of 3x, and also at the same time I want to actually have a domain for this. So if I just tab out of the bracket, now to insert a domain, I'll just go control with the equal to sign, and it gives me a vertical line. Now that vertical line is actually a conditional line, so that's going to put the domain over here. So let's put a domain as 0 to 2 pi. So now to find pi, you click that key there. Sorry, I should have done that, and then I'm going to, and then pi. Now just another thing that I want to mention, every time I click this, if I keep clicking, I actually can pick up whatever I want from there. So if I want Euler's number, that's where I should be. Okay. So now if I click enter, I should have the graph for the sine function in the 0 to 2 pi. I think that's what the domain I put. Okay, now I want to maximize the view for my graph. So if I click on any of these points, I could actually go and do the Windows setting using the menu, and then I've got all these various options. However, I'm going to do it differently. So if I click on this extreme value on the x-axis, which is -10, let's say I go and change that to negative pi. So I'm just going to pick up pi, and you will realize that actually I don't have to have integer values there or any real number. I could actually have values like pi or Euler's number on my scale. Now if I click tab, it will accept the value and go to the next cell where I can so that's on the y maximum value. Now the graph only goes up to 1, so let's just go and change that to 2, tab, and now let's change that to 3 and pi, and then I tab and change that to -2. The other thing that I want to bring out now, if I want to see values in the exact form, before I do that, now at the moment that value is 0.5, that's the scale there. If I want, I can change that, and I can put that also in terms of say pi. Let's go and put that as pi on 6. So now that's pi on 6. So now if I go menu, geometry, and point and line, so number 1 and then point on, and if I go and put a point on the graph anywhere, now I need to click escape, see, otherwise it will keep putting points. So I click escape, and now I select the x coordinate, and let's say if I there, so that's pi, and on 9, let's say, you will see it gives me the value in the exact form. Okay, now next we are going to graph a relations of got relation 1, which is in terms of x and y, and I've already entered y equals 3 log base e x minus 2. So that's my graph there, and if I click enter, that's what I get. Now if I want to actually do the inverse for this, that's what I've done. So now by default it's gone to relation 2, and all I've done is I've taken relation 1 and swapped the positions of x and y, and I actually get this as my relation. Now if I want to put a square grid, let's say I change that to negative 32, let's say, and change that to 32. And now if I go I probably already have a square grid, but if I go to Windows Zoom, which is number 4 is zoom, and then if I go to option B, I know that is a square fit, and it actually does a square graph over there. Next we are going to look at parametric graphs. Control menu, and then we are looking at parametric, which is number 4, and I'm actually now to do a parametric graph. That is the entry I have made, and I've gone from -2 to 1, and I've just put a table there. These are the values it takes, and that's the graph that we are going to get. Now I can go and change the domain for the parametric graph, and you'll see I've now gone from -1 to 1, and this is the graph I get. So you can see how it goes in steps. That's the graph I would get. Lastly, let's go and do a polar graph. Now the polar graph has to be done in terms of r and theta. So if I open the graphing template, I will get r1 by default as my first one, and I'm entering 5/2 sine of 5 theta over 3, and I'm going from 0 to 2 pi, and step size is pi by 12, and that's the graph I am going to get. Lastly, look at graphing differential equations. Now once again, when I go to that, I've got this y2 is the derivative there, and the equation is y2 plus x. Those are the initial conditions. I can have more than one initial condition, so I've actually edited the initial conditions and I put some more, and that is why I actually get 4 different graphs over there. So that's plotting differential equations, and thank you for watching this video.